Okay, so in this video, we are going to discuss some more past paper questions, NET past paper questions, which are related to number systems. So let's get started. All right, so here are some questions which are basically sample questions for NET, which are related to number systems. Okay, so the very first question is, if x minus 3 mod is less than 5, then x lies between. Okay, now we have x minus 3 mod, right? So I've been telling that before this as well, that whenever we have mod, either it's in an equation or in any inequality, we need to do a similar step for mod. Okay, we write down this inequality two times without the mod. How? Like this is with mod, so I will write it down like this: x minus 3 less than 5. This one is as it is without the mod, and the other one is going to be a bit different. It would be x minus 3 greater than minus 5. So basically, I know that if I have x, let's say x is a number, it x mod would be x. If x is a positive, let's say it's positive integer. And let's say now I have minus x in mod, which means that inside the mod I have a negative integer, and I'll also get x for this. Okay. So this implies that whenever I am opening the mod, I get positive x. Okay. No matter if initially I had the positive integer or negative integer. So in short, the story is whenever you come across such a question where you have to solve, where you have to find the range, which basically means we need to find the range of x or we need to find the value of x, right? If it would be any inequality, you need to find the range. If it would be any equation, you'll be finding the exact value. Okay. Coming to the point, since this has mod and you need to get rid of mod in order to find the range of x. So for getting rid of mod, whenever we have mod, we end up getting two equations for one equation. So in the question, we had x minus 3 mod less than 5. I will write it as 1 and 2. Okay. Now we can simplify it easily. X would be less than 8, that is 5 plus 3, and x would be greater than minus 5 plus 3, that is x would be greater than minus 2. Now, if I combine these two ranges, I am going to get that x is between minus 2 and 8, right? So this is what I'm getting. Now let's check out the options. In the options, we have minus 2 and 8. Yes, so A is the answer, okay? Because x lies between minus 2 and 8, so A would be the answer. Okay, so we are done with the first question. Let's talk about the second question now. Okay, now we have, again we have mod, x square mod, okay? Now here they have not mentioned that x is a complex number, a real number and stuff like that, okay? So we need to think of it as a real number, right? So here in the question, you have been given with a real number with a square on it and it has a mod. Now, one thing is for sure, we know whenever we have a squared number, it is going to be positive definitely, right? So whenever we have x square, it is going to be positive. And the second thing is, even if it's negative, the fact that we have mod around it would give positive answer, okay? So here clearly, the mod of x square is going to be x squared, like this value as it is, but with positive sign. Since this was already positive, so we did not change much. But if it was minus x square mod, then even then we would have ended up with x squared as our answer. Why? Because we have mod, and what mod does is, if the integer is positive, it would come as it is. If the integer is negative, mod makes that negative integer positive. So in short, mod x square would be x squared, right? Because whenever we have mod and the integer gets positive, it was already positive, so we will just write it down there. Okay, we're done with the second question as well. Now we have third question. Okay. Now the question says, if z is a complex number, then the minimum value. Now I repeat, z is a complex number, right? Let's just talk about z first. So if z is a complex number, I can write z as x plus iota y. So this implies that x and y belong to real numbers, right? This is the definition of a complex number. This is how we define complex numbers. Okay, it's not something which you have come across for the first time. This is something that which we know from the definition of complex numbers. Okay, now if this is a complex number, and here we need to find the minimum value, right? We need to find the minimum value of z mod plus z minus 1. Okay, so we need to think of different scenarios. Okay, let's say we take z equals 0. Why? Because z is x plus iota y, and x and y can be any real numbers. Okay, so if x and y both are 0, z would be 0. Okay, let's see what would be the value of this expression when z is 0. So z mod plus z minus 1 mod is going to be 0 plus 1, because like 0 mod would be 0 and minus 1 mod would be 1. So I am going to get 1. Okay. All right. Now let's say I want to find the minimum value. So let's say if I say that, what if I keep y 0 and I keep x minus 1? That is, what if I keep minus 1 plus 0 iota, right? Now, obviously, x and y belong to real numbers, so we can choose any number of our choice. Any real number can come as x and y. So here, since I have to find the minimum value, so I can choose values according to myself. Okay, so I initially chose z equals 0 and I got 1. And now I'm saying that if I choose z equals minus 1, now what made me choose z equals minus 1? This would basically be minus 1, because like we have to find minimum value. So I can see that if I choose, sorry, this would be plus 1. This would be plus 1. Yeah. Okay. Yeah. So basically, if I choose z equals 1, I know that this mod would basically become 1 minus 1, that is 0. So this made me choose this, right? All right, now let's check out the value of this expression. Z plus z minus 1 is going to be, it is going to be 1 mod plus 0, that is again 1, right? So I have tried out two combinations, and it is obvious that these two were the only options which would have given me a minimum value, right? So for both of these, I'm getting 1. So 1 would be the minimum value of this expression, right? So I repeat, here the question was to find the minimum value of this expression. Whenever you come across such a question, things would be on you. Like you have to choose Z, and you need to think of all the cases where you would end up getting a minimum value, right? One thing is certain, that both these functions which are being added have mod around them. So definitely the answer is going to be either 0 or it is going to be a positive number, right? So this cannot be the answer, right? This cannot be the answer, right? Okay, and again, we tried getting 0 by first using z0, but obviously we had minus 1 mod, so we will get 1. And then we tried making this part 0, but when we tried making this part 0, we got 1 through this part over here, right? So our z was 1. When z was 1, so we got 0 for this part, but for this part, we have 1. So 1 is the answer, right? So in short, for every attempt, we are getting 1. Obviously, if you're getting 1, we cannot say that B would be the answer, because like we're talking about the minimum value, and we are not being able to get 0 as well, right? We have tried taking z equals 0. We have tried taking z equals 1. If we try taking z equals minus 1, our value would be even more, right? So this means that 1 is the minimum value, which would be the option. So one thing was clear, since two functions which are being added have mod around them, this means that it cannot be negative, and the option had minus 2. So all you need to do is simply cancel out such options, okay? Because like it is obvious the value would be positive. Okay. Let's talk about the fourth question now. Okay. So the question says, if z1 by z2 is purely imaginary, then, all right, then, okay, so this is the fraction with mod which we need to find. And what we have been given is that z1 by z2 is purely imaginary, okay? So let's just write down this English into a mathematical statement. If z1 by z2 is purely imaginary, this implies that it is going to be a complex number with imaginary part only, okay? This is what this purely implies, that this fraction would be a complex number, but with imaginary part only. So I don't know what that imaginary part would be. Let's say I just take that it would be y, okay? So this would be iota y, right? This is what I'm saying. Since this is imaginary, I don't know what y would be, but it would be with iota because it would only have the imaginary part, right? So this is what I'm getting. So I can say that z1 is equal to z2 y iota, right? I can write this, okay? All right. So I'm done with my data. Now I need to plug in this z1 in this expression just to simplify this, okay? So I have z1 plus z2 divided by z1 minus z2 mod, that would be equal to z2 y iota plus z2 directly divided by z2 y iota minus z2, right? I got this by using z1 equals this in this expression, right? So this is what I'm getting. Okay, now let's just take z2 common in both numerator and denominator. So if I take z2 common, I am going to get y iota plus 1 divided by y iota minus 1, okay? And with a mod here, okay? So obviously these two can be cancelled and I am left with y iota plus 1 divided by y iota minus 1, okay? Now we have mod around this, so by using the property of mod, we know that if we have a fraction which has mod around it, so we can split it into numerator and denominator like this. Y iota plus 1 mod would be divided by y iota minus 1 mod. Okay, so I am clear with this part. Now I have to basically use the mod function for both numerator and denominator. Okay, so what is the mod function? Under root, then I write the real square. Real part of this complex number is 1. 1 square plus I write y square, okay? 1 square by y square divided by, now again I will get under root and I am going to get minus 1 square plus y square, okay? So this is basically 1. So these and these can be cancelled. Numerator and denominator are same. So I'm going to get 1. So 1 is the answer. So B is the answer. Now, if you look at this question directly, it would make you feel that it is a difficult question, stuff like that, but don't worry. For NET, obviously, this time is a challenge, but you cannot just waste time in thinking that, how to do it. You just cannot waste time over there. Before thinking, just write the English statements in mathematics. Like we were told that Z1 by Z2 is purely imaginary, so I simply just wrote this equation out of this English statement, and then I just made Z1 the subject, and I plugged in Z1 in this equation, and I got 1 as the answer. Okay, so just try making things easier for yourself by first jotting down the data, by first writing down the mathematical equations, inequalities out of the English which you have been given in the question. Okay. All right, so we are done with the fourth question as well. Now we have fifth question. Okay. The modulus of the complex number. Now we have a complex number. Z is 1 plus iota tan alpha, right? And the modulus. Okay, so we need to find Z mod. We need to find this mod is basically going to be under root real square plus imaginary square, right? Okay. I have not even read the question and I've directly just, written down this part in maths, right? Okay, equals what? Okay, so this was the question. I need to find what under root 1 square plus tan square alpha would be, right? Okay. So I know in trigonometry that 1 square, that is basically 1. I'll just write it down as 1. 1 plus tan square alpha is basically secant square alpha. So I can simply replace this as under root secant square alpha. So I am going to get secant alpha. So this would be the answer in this case. All right, now let's talk about the next question. Okay, so we are done with this fifth question. And now we are going to discuss the sixth question. Okay. So for the sixth question, we have if cos theta plus iota sine theta square is x minus iota y, then okay. So I need to find x square plus y square. But before even going to the question part, let's just, consider this thing only, okay? So we have cos theta plus iota sine theta square, okay? So here I've just written the left hand side, and now I am going to simplify it. This is going to be cos theta square plus iota square sine square theta plus 2 iota cos theta sine theta, right? So let's just write iota at the end instead of writing it with 2. Okay. All right. Now this is basically cos square theta, and iota square is -1. So it would be minus sine square theta plus 2 cos theta sine theta iota. Okay. So I am done with the left hand side. Okay. Now this is basically equal to x plus iota 1, right? I need to compare it with x plus iota y, and after my comparison I can clearly see that x is basically this part and y is basically this part. Okay, so here they want us to find x square plus y square. Let's just write down x square. So x square is going to be cos square theta minus sine square theta whole square, right? And y square is going to be okay, y square is going to be 2 cos theta sine theta square. All right, now we just have to open up things. So for cos square I am going to get cos to the 4 theta plus sine to the 4 theta minus 2 cos square theta sine square theta plus 4 cos square theta sine square theta. Okay, so I got plus 4 cos square theta sine square theta from here, and I got rest of the thing from here. Okay, now let's just simplify it. So we have cos 4 theta
plus sine to the 4 theta plus 4 cos square theta into sine square theta. Okay, so this is what I have finally, and minus 2 plus 4 would basically be 2. So this is going to be 2. Okay, now if I look at it carefully, this is basically a plus b whole square, where I get a square b square plus 2ab. Okay, so this means that I have a as cos square theta and b as sine square theta, and I need to square it up. That would basically be 1 square. That is 1. So the answer is A. Now here the question was to find x square plus y square, but the actual task was to find x and y, and we did that by comparison. For comparison, we had to simplify the left hand side first, which we did by expanding cos theta plus iota sine theta square. Once we were done with the expansion, we got this, and we can see that x is cos square theta minus sine square theta, because x is the real part and the real part in this is this function, and y is the imaginary part. So this is the imaginary part, 2 cos theta sine theta. And finally, after just getting x and y, I have to square x, I have to square y, and I got 1 as my answer. Okay. All right. Now let's discuss the seventh question. Okay, so for this question, z is 4 plus 6 iota square. So z is 4 plus 6. Iota square is minus 1. So this is basically 4 minus 6, that is minus 2. And I need to find z mod. I need to find z mod. So since z is minus 2, z mod would be minus 2 mod, that is going to be 2, because here clearly this is a real number, and in case of real numbers the definition of mod changes. In case of complex number we have a different definition. Okay, since it is a real number, it was negative, so we used mod to make it positive, so the answer would be 2. Okay, so we are done with this part. Now we have the eighth question. All right. Now the eighth question is, if z equals 2 plus 7 iota divided by 2 minus 8 iota, then, and this is the new fraction. Okay. Now we can see clearly that the only difference in both the fractions is that the numerators are basically conjugate and the denominators are conjugate. Like the conjugate of 2 plus 7 iota is 2 minus 7 iota, and the conjugate of 2 minus 8 iota is 2 plus 8 iota. Okay, so if I consider z mod, this is basically going to be 2 plus 7 iota mod of the numerator divided by mod of the denominator, that is basically 2 minus 8 iota, and I would end up getting 2 minus 7 iota divided by 2 plus 8 iota. So this is what they have asked. This is what they have asked. We have the same fraction now by basically using z mod. So B is the answer. So obviously in exam, in NET, you are not going to check every option to know the answer. You can see that the only difference here in numerator and denominator is of sign of the imaginary part, which basically has to do only with conjugate, right? So this is a property. If z is a fraction and if we are finding z conjugate, so z conjugate would be equal to the conjugate of numerator divided by the conjugate of denominator. And finally, after getting the conjugates, we got what we had to find, and that is z conjugate. So B is the answer. Okay. Now The last question of this topic is, if z is cos theta plus iota sine theta, then 1 by z is, okay, now let's just write down 1 by z. 1 by z would be cos theta plus iota sine theta. Now, obviously, I can see that in the options, I do not have any option of this type. So this means that I would have to further simplify it just to, make it look like any of the given options. All right. So whenever we have complex number in denominator, in order to get rid of the imaginary part from the denominator, what we do is we just take 1 over cos theta plus iota sine theta, and we multiply it by a fraction which is basically 1 cos theta minus iota sine theta. I'm multiplying it by a fraction which is basically 1. By the fact that it is basically 1, I mean that since numerator and denominator are same, I can cancel it out and I would get 1. So in mathematics, you can multiply anything with 1. So I have multiplied it with 1. Okay. All right. Now I'm going to get cos theta minus iota sine theta divided by, now this is basically a plus b and this is a minus b. So whenever I have a plus b, a minus b, I can write it as a square cos square theta minus b square iota square and sine square theta. So the denominator would become cos square theta plus, because iota square is minus, so minus into minus is plus, sine square theta. And this is basically 1. So I have one denominator, so this means that cos theta minus iota sine theta is the option. Okay, so the answer is C. Right, so we are done with all the NET sample questions which were related to number systems.